So now we'll move on to exercise 1G, where we're solving some inequalities. And so I'll just write up the inequality we have to solve, and then we'll go into solving it. So the critical points are at x equals 0 and x equals 3. And we're trying to go less than, and because we don't have negative x's involved, it's going to be like this. So it's going to be between these 2 points. B, x minus 3, x plus 2 greater than 0. Critical points, x equals 3, x equals minus 2, and we're trying to go greater. So we want x to be greater than 3, or x to be less than minus 2. X minus 6, x minus 4, less than or equal to 0. Critical points, x equals 6, x equals 4. And again, we're going less than, so we want it to be between those two numbers. We want less than, and it's a U-shaped parabola. D, 2x plus 3, x minus 2, less than 0. Critical points at x equals minus 3 over 2 and x equals 2. And we're going less than, and again, I keep saying this, that we want to go between those 2 points. E, 5 minus x, x plus 6. Right. Here is where we don't have a U-shaped parabola, but an N-shaped parabola. So if we want to go greater than 0, we have to go between these 2 points again. So critical points at x equals 5 and x equals minus 6. And we want it to be between those 2 points. And see, notice how we have that minus x again. So it will be an N-shaped parabola. And we want to go less than 0. So if we want to go less than 0, we have to take less than something and greater than something. So critical points will be third, x is a third, and x equals minus half. So we want x to be strictly less than minus half and x to be greater than a third. Two. A, okay, x squared minus 25 greater than 0. Let's factor it. Critical points at x equals minus 5, x equals 5. And remember, the x squared is positive, so it's a U-shaped parabola. And if we want to go greater, we're going to have to go less than the smaller one and greater than the bigger one. And I should note, it's obvious, but keep the same sign. X plus 5, x plus 2, 0. Critical points at x equals minus 5, x equals minus 2. Right, so x needs to be less than or equal to minus 5 or greater or equal to minus 2. C, x squared plus 6x minus 7 greater than 0. X plus 7, x minus 1 greater than 0. Critical points at x equals minus 7, x equals 1. So, and we want it to be greater, and it's a positive x squared, so it's x is less than or x is strictly less than negative 7, or x is greater than 1. 14x squared plus 17x minus 6 less than or equal to 0. AC equals negative 84, so we just need to figure out things that will multiply to get the answer that we want. That's looking like 21x minus 4x minus 6 less than or equal to 0. And we just have to factor this. So critical points at x equals 2 over 7, x equals minus 3 over 2. And we're going less than 0. Oops, this one, because we're doing less than 0, needs to be between the 2 points. And then we'll do this. Because we're going less than 0, we need to be between the 2 points. AC will equal 120. Six x squared minus 8x minus 15x plus 20 strictly less than 0. Two x minus 5 bracket 3x minus 4 less than 0. Alright. So critical points at 5 over 2 and 4 over 3. We want to be less than 0, so we go between the 2 points. And let's factor so critical points half and minus 4. So minus 4 and notice how this is a negative parabola. So when we're trying to go less than 0, we actually go away from each other, right? So we want it to be x is less than -4 and x is greater than 1/2. Okay, we'll just keep going. 3a, x squared less than 36 minus 5x. X squared plus 5x minus 36 is less than 0. X squared x plus 9x minus 4 is less than 0. Critical points, x equals minus 9 and 4. And we're going less than 0, so we just want to be between those 2 points. (15x) less than x squared plus 56. X squared plus 56 minus 15x will be greater than 0. X minus 7, x minus 8, less than 0. Critical points 7 and 8, and we want to be greater. So x needs to be less than 7, or x needs to be greater than 8. C, x plus 10 less than 12 minus x. X squared plus 10x, and that becomes 11x when we add that x to from the other side, less than or equal to 0. X plus 12, x minus 1, less than or equal to 0. Critical points, x equals minus 12, x equals 1. So this is the answer. D. Oh. X squared plus 4x less than 3x plus 2. So x squared plus x minus 6 less than 0. I've just expanded that and moved it to one side. A factor. So we got -3 and 2 as our critical points. And that's our answer. Okay, now we have this. And we should expand x. Right, minus x squared minus 3x plus x minus 2x plus 3 less than x minus 1. And then I'll just move everything over to the other side so the factoring will be easier. Critical points, I should say. And remember, we're trying to go, well, for this one, we're trying to go greater than, so x is greater than 1, or x is less than minus 4. Four minus 7x minus 2x squared minus is less than 0. Move everything over to the right side. Remember to swap the sign. Factorize So critical points, x equals half or minus 4. And in this situation, we're going greater than 0. So x is greater than half. X is oops, hang on, I've accidentally done the we've redone the question. F is 4x plus 3, 3x minus 1 less than 2x, x plus 3. 12x squared plus 9x minus 4x plus 5x minus 3 less than 2x squared plus 6x. 10x squared minus x minus 3 is less than 0. Two x plus 1 minus 3, 2x plus 1 over x minus 3 bracket 2x plus 1 less than 0. Critical points, x equals 3 over 5, x equals minus half. And we're going less than 0, so we want to be between the 2 points. G, x plus 4 squared greater or equal to 25. And we can kind of split that up into cases here because it's a perfect square. That's either going to be greater than 5 or it's going to be less than negative 5. And so that'll be the answers. H, x minus 2 squared less than 14 minus x. I would expand. Move to one side. Factorize. We got critical points at 5 and negative 2. X will have to be less than negative 2 or greater than 5 in order for it to be greater than 0. I, 6x, x plus 1, less than 5, 7 minus x. 6x squared plus 6x less than 35 minus 5x. 6x squared plus 11x minus 35 is less than 0. AC is negative 210. So that's going to be something like that. And then excellent, that's factorizing. Critical points, x equals minus 7 over 2, x equals 5 over 3. And we want to be less than 0, so we will do between the 2 points. Question 4. Find the range of values of x for which 5 over 2x squared plus x minus 15 is less than 0. Whew, okay. All right. Now we need to see what we can do here. We're essentially figuring out the ways where 2x squared plus x minus 15 is less than 0. Because if you divide 5 by a negative number, it'll be negative. So we can factorise this. And so we have critical points there, and because it's less than 0, we're going for less than 0, and it's a positive quadratic. We'll go between the values. Now we need to find the set of values of x that satisfy two inequalities. And essentially what we do is we just solve both of them and then take the intersections. So this one here. So we're going to have x is greater than or equal to 5, or x is just going to be less than or equal to negative 2 on that side. Now this either has to be less than 4, so less than 9, or it needs to be greater than negative 2. And now we need to judge the intersection. It may help to do a bit of a number line. And we can see that the only spot where one of the things from both of them, at least one, crossover is between 5 and 7. And that's, it can be equal to 5, so 5 less than or equal to x, but it must be less than 7, seen by that hollow dot. And for B we'll do similar stuff. So x plus 7, x minus 3 is less than 0. So critical points, minus 7 and 3. And to get this we would want between the two. And then on this side we have minus 8 and minus 1. So critical points 8, 1. We want x to be greater than 8 or x to be less than 1. So on a number line, let's show this. Minus 7, 3, 8, 1. And we can see that one of the inequalities will look like this. Then that 8 will be like that. Then this 1 here, sorry, wrong direction, can go like this. And so we can see at this point here, we've got something from both inequalities overlapping. And that's between -7, but it has to be less than 1. See, a similar thing again. Minus 2 and 1 that we have as critical points on that side. 3 and -1 on this side. And we want both of them to be greater than 0. So it will have to be less than -2, greater than 1, greater than 3, or less than -1. Pull up a right, so we can either have this oh, this is equals or equals to, by the way. And here we can see that we actually have 2 bits. We can have x as strictly less than -2, that works and overlaps. And on the other side, it can be greater or equal to 3. Six. Now we need 2x to the power of x squared minus 3x minus 40 to be greater than 1. And the way we can do this is knowing that 1 is the same as 2 to the power of 0. So x squared minus 3x minus 40 just needs to be greater than 0. And if we factor this, we get critical points at 8 and -5. X equals 8 and x equals -5. We want x to be less than -5 and x to be greater than 8. Next, we have slightly harder inequalities. X over x minus 1 greater or equal to 3. Now what we need to do here is we have to be careful, because if we multiply by x minus 1, we don't know if it's positive. So we don't know if we have to change the sign. So what we will do is we just need to identify critical points. This on a graph in general has sort of this reciprocal shape, and it's got I've done this very poorly, it's got an asymptote horizontally and vertically. So we have essentially, we want to determine where the horizontal asymptote is, where the vertical asymptote is, and to get the other critical point where it will potentially equal 3. So say this equals 3, we want this part of the graph. But also we don't know if maybe part of that crosses over there. So we have to figure that one out. So we'll determine a few critical points. One will be when the to get the vertical asymptote, if we make the denominator 0, that is a point where y is undefined. So that's where you'll have that vertical asymptote, because it will get really big or really small, like as in infinity positive and infinity negative. So x is 1. So that's one of our critical points. And we'll say it's the vertical asymptote. The next thing we need to do is figure out when x over x minus 1 equals 3. So now we've determined the two critical points, the vertical asymptote, the point where this graph will equal 3. And then what we will do is I would make a bit of a table. Like this. And then I would see what would happen for each of these. Okay, if x was less than 1, we would get a negative number on the bottom, making this negative. So we'd get a negative number. So that's less than 3. So that does not work. At x equals 1, undefined. But between 1 and 1.5, we will test a few numbers between them. Say if we did 1.25 over 1.25 minus 1, we get 5. And at this point it's greater than 3. And at this point it's equal to 3, and at this point it's less than 3. So we would say that this range would be 1, strictly less than x, but it can be equal to 3 over 2. B, x minus 1 over x plus 1 greater than x. And again, I'd simplify this a bit. And now I'd again do the critical points. Where is it undefined? Where is the vertical asymptote? And when does it equal x? So x plus 1 equals 0, x equals negative 1. This is the vertical asymptote. Then let's say this equals x plus 1. We get minus x equals x, and the only solution for that would be x equals 0. So now we have the critical points at minus 1. So let's say x equals minus 1, x is less than minus 1, x is between minus 1 and 0, x equals 0, and x is greater than 0. When it is less than negative 1, we'll get a positive number over a negative number, because we're doing a squared, which will always make it positive, then minusing the negative, which will make it negative again. But then if it's less than 1, the denominator will be less than 1. So in that case, it's always going to be less than x. And then at x equals negative 1, you'll get undefined. But then between negative 1 and 0, you'll be greater than x. You just need to try and test out, I recommend you just test out a few values, but you can just think about it logically. That'll be, you're getting because you're between negative 1 and 0, when you add 1, it'll be slightly positive. It'll be a small decimal number, but it'll be positive. And then with positive on top, dividing by a decimal, you'll make it even bigger. So, of course, it's going to be greater than x. Then at x equals 0, just substitute it in, because 0 squared minus 0 is 0. And when you divide it by 1, that's 0. It's not greater than 0, it's only equal to. And then if x is greater than 0, then it becomes less than x again. So the answer is minus 1 less than x, strictly less than 0. C, x squared minus 9 over x minus 1 greater or equal to 4. Again, determine when the denominator is 0. Then see when it'll equal 4. Oh, and we have two solutions here. So we have several important points. X equals 1, x equals minus 1, and x equals 5. And then so let's think about it critically. We know that at x equals negative 1 and negative 5, it's equal. So that would satisfy that inequality because it can be equal. At x equals 1, it's just undefined, so that's when there'll be a gap. But then at x equals, if it's less than negative 1, you will be dividing by a negative number, and you'll be dividing a positive number by a negative number. And even if you're not, so like anything less than minus 3, anything greater than minus 3, it's like minus 2 squared, that's 4, minus 9. That is negative, yes, minus 5, but then when you divide it, it's still going to be a positive number, but less than 4. So that's always going to be less than 4. So that doesn't work. And it's the same story for 5. For being less than 5. It's going to be, no. But if it's greater than 5, you will, because of that squared, it'll make it quite big, and of course it's going to be greater than 4. And then between negative 1 and 1, so like let's try 0. 0 minus 9 over minus 1, that's 9. That is greater than 4. So I think that would work there as well. You just have to test out a bunch of values, and then it will give you an idea, because you've identified all the critical points, all the regions where there is no significant change. So this tells you that x needs to be greater or equal to negative 1. It must be less than 1, because that 1 is undefined. And then it can be equal to 5. And it can be greater than 5. D. X squared minus 2x minus 15 over x minus 2 greater or equal to 0. Again, find all the critical points. Then see when it equals 0. So we have the points at 2, 3, and 5. If it is less than 2, you're going to get a negative number on the bottom, and it'll be positive on top, because a quadratic looks like that. So it will be, it's undefined here, but at less than 2, at less than 2, at less than 2, it'll be negative, so less than 0. Between 2 and 3, you'll be getting a decimal on the bottom, so that'll make the thing on top rather large. So that'll be well, you know that between 2 and 3, this parabola on top crosses at 3 and 5. Less than 3, it'll be positive. So you've got a positive on the top, then when you have something between 2 and 3, minus 2, that's a positive on the bottom, so it'll be greater than 0 at that point. At 3, it'll be equal to 0. At 5, would be equal to 0. Between 3 and 5, that's this bit. You'll have a positive on the bottom, but you'll have negative on the top, so that'll be less than 0. And then at greater than 5, it'll be greater than 0. So you need it to be I've made a mistake there. Hang on. Let's rearrange this. Let me recharge that one. Minus 3. Okay. At minus 3, we know that, minus 3 minus 2 is a negative 1. That will be negative. But we know that at minus 3, that quadratic equals 0. So that's fine. And we know that at a point less than negative 3, it will be positive on top, but negative 3 minus 2 is minus 5, and so we're going to keep getting more negative on the bottom. So it'll be less than 0. Between negative 3 and 2, you get negative numbers on the bottom, but between negative 3 and 5 on the quadratic will also be negative. So negatives cancel out. This part will be greater than 0. At 2, we know it's undefined due to the asymptote. Between 2 and 5, let's see, 3 minus 2 or whatever, that's positive, but on top we're still in the negative region, so it'll be less than 0. At 5 it's equal to 0, and then so at 5 greater than x, we know it's going to be greater than 0. So we want negative 3 less than or equal to x, strictly less than 2 because that's an undefined point, and then x is greater or equal to 5. E. X squared plus 4x minus 5 over x squared minus 4 is less than or equal to 0. Again, I keep saying this, we need to find the vertical asymptotes first. We actually have two vertical asymptotes here. And now we need to know when it will the quadratic will equal 0. And now we will do our little table. Okay, when it is less than negative 5, we have, I might even write a bit of a chart. On top, when we have less than negative 5, that quadratic will be positive. On the bottom, we'll have a large squared. We get progressively larger squares, and we're only subtracting 4, so it will still be positive. So the result will be greater than 0. At negative 5, we know it's 0 on top, so it doesn't matter what's on bottom. It's going to be equal to 0. At minus 2, on top, this is in the region where it's less than 0, so it's going to be negative. Well, negative, and on bottom, it's 0, so it's undefined. Oh, and I should do region between here. Negative on top, and say a number like negative 3 squared minus 4. It's still going to be positive, but it's when you divide those, it'll be less than 0. We're still in that negative region for the parabola, so it's a negative, but on the bottom, it'll be also negative actually, so that'll be greater than 0. Because the absolute value of it is less than 2, so the square of it will be less than 4, giving you a negative on the bottom. At 2, that's still negative, but that's 0, so this is undefined. Then at between 2 and 4, on top, you've still got a negative. On bottom, you've got positive, though, because you can have like something like 3. 3 squared minus 4 is 5, which is positive. So that gives you less than 0. At this point, it's 0. So it doesn't matter. That's just going to be equal to 0. Greater than 4, that's positive. Still positive. So it's going to be greater than 0. So we want it to be equal or less to 0, it says. Tick, 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 tick. So we want it to be minus 5, less than or equal to x, strictly less than minus 2, or over here, oh, what have I bungled up here? This needs to be 1. Oops. This will be 0, so that'll be 0, but between here, you're going to get a positive on top, but a negative on the bottom, so less than 0. So on this side we have 1 less than or equal to x, less than 2. If x minus 3 over x plus 4 greater or equal to x plus 2 over x minus 5. Oh, this is nasty. And let's just figure this one out. We need to find all the critical points. So x is equal to minus 4 will be 1, because that's a vertical asymptote, or x is equal to 5. Then we need to figure out when they'll be equal to each other. And we'll multiply. X squared minus 8x plus 15 equals x squared plus 6x plus 8. X squareds eliminate, 14x equals 7, x equals 1/2. So those are our critical points. Negative 4, half, and 5. We know that this point we've got undefined, this point we've got undefined. But less than negative 4, the negative will be on bottom. There'll be a negative on bottom, but it'll be a negative on top. So negative, negative makes a positive. Then for between negative 4 and half, you've got a positive on the bottom, but you're still going to have a negative on top. So you get a negative less than 0. So we don't want that, we don't want that. Okay, half. We know that's the point where it all equals 0. So that's a tick, that's when they're equal. So, and then between half and 5, we're going to get a point that is the stuff that's less than, because it's coming after this sort of thing. So that's greater than 0, tick, and then at 5, it's undefined. So we get this, and you just have to substitute in numbers within these ranges because we know we've identified the critical points, and anything between them will tell you the same story. So that's why this stuff works. Anyway, so that's inequalities. In the next video, we'll be moving on to the discriminant and using that.